some question of CSIR NET and GATE and any competitive exam about the metric space. The question is, let D and D dash be metric on a non-empty set X. Then which of the following are matrices on the set X? Option 1, rho 1 xy equal to dxy plus d dash xy, where for all xy belongs to X. That means we have to prove if D and D dash be metric space on the set X, then their sum also be metric space on the set X. Option 2, rho 2 xy equal to d of xy times d dash xy for all xy belongs to X. That means we have to prove if D and D dash be the metric space, then their product also be metric space. Option 3, rho 3 xy equal to maximum of the set d of xy comma d dash xy. We have to prove this is also metric space. And option 4, rho 4 xy equal to minimum of dxy comma d dash xy. We have to prove this is also metric space. And this type of proof actually very important for not only competitive exam, for higher study also. First, we have to prove if D and D dash be metric space on the set X, then their sum be metric space. And I will prove it. This is very easy type proof. Since d of xy and d dash xy be metric on X, then obviously that imply d of xy greater than equal to 0 and d dash xy greater than equal to 0, and rho 1 xy equal to obviously their sum d of xy plus d dash xy. And since d of xy greater than equal to 0 and d dash xy greater than equal to 0, then obviously that imply their sum greater than equal to 0. That means option first of metric space has satisfied. Then option 2, since D and D dash to be metric space, so d of xy equal to d of yx and d dash xy equal to d dash yx. Okay, then we can write rho 1 xy equal to d of xy plus d dash xy. We can write this as d of yx plus d dash yx. Obviously d of xy yx plus d dash yx equal to rho 1 yx. That means obviously rho 1 xy equal to rho 1 yx. That means second condition also has satisfied. The third condition, when x equal to y, then obviously d of xy equal to 0 and d dash xy equal to 0. Then rho 1 xy equal to their sum d of xy plus d dash xy. This equal to 0 when x equal to y. Are you getting? Oh well. Now I will apply the triangle inequality. Since rho 1 x comma y equal to d of x comma y plus d dash x comma y, and since both d and d dash are metric space, so we can apply here triangle inequality for d. Then this would be d of x comma z plus d of z comma y, and this would be d dash x comma z plus d dash z comma y. And we can write this as d of x comma z plus d dash x comma z plus d of z comma y plus d dash z comma y. Okay, and obviously by definition this is less than equal to rho 1 x comma z and this is rho 1 z comma y. That means rho 1 x comma y less than equal to rho 1 x comma z plus rho 1 z comma y. That means triangle inequality also has satisfied. So obviously if D and D dash be the metric space on the space X, then there are some obviously metric space on the set X. Are you getting? Well, now we have to prove if D and D dash be metric space, then their product also be metric space. For this, consider rho 2 xy equal to d of xy times d dash xy where for all xy belongs to x. And since d and d dash both be metric space on the non-empty set capital X, so obviously d of xy greater than 0 previously similar to before example and d dash xy greater than 0, that means their product also greater than equal to 0. That means obviously first condition has satisfied. Second condition, since both are metric space, so obviously d of xy equal to 0 and d dash xy equal to 0 means x and y both same. So if d of xy and d dash xy equal to 0, that imply obviously rho 2 xy equal to 0 and that imply x equal to y. Similar to before, symmetry property also would be satisfied, rho 2 xy equal to rho 2 yx, since d and d dash be both metric space. Next, we have to prove the triangle inequality rho 2 xy less than equal to rho 2 xz plus rho 2 zy, where for all x, y, z belongs to x. We have to prove this. And since given rho 2 xy equal to d of xy times d dash xy, just put the value, then this would be rho 2 xy less than equal to d of xy times d dash xy plus, put the value here also, sorry here not y, here z, put the value here also for rho 2 zy, then this would be d of zy times d dash zy. Now calculate, then this would be less than equal to, after calculating, d of xz plus d of zy times d dash xz plus d dash zy. Okay. Now after multiplying, this would be d of xz times d dash xz plus d of xz times d dash zy plus d of zy times d dash zy plus d of zy times d dash xz. Okay, and this is actually the less than equal to rho 2 xz and this is plus rho 2 zy plus d of xz times d dash zy plus d of zy times d dash zy. Okay, and notice here the extra term. So this expression cannot be possible less than equal to rho 2 xz plus rho 2 zy. Are you getting? This is cannot possible. We cannot write rho 2 x y less than equal to rho 2 xz plus rho 2 zy. Are you getting? That means if D and D dash be two metric space on the set X, their product cannot be metric space on the set X. Okay? Well. And option 3 indicate rho 3 xy equal to maximum of the set D of xy comma D dash xy. We have to prove rho 3 be a metric space. Since D and D dash both metric space, so obviously their maximum always greater than equal to 0, and that means first condition has satisfied. Second condition, when x equal to y, then obviously d of xy equal to 0 and d dash xy equal to 0. That means their maximum also equal to 0. That means rho 3 xy equal to 0, and rho 3 xy always similar to rho 3 yx. Now we have to prove the triangle inequality. For triangle inequality, consider d of xy greater than d dash xy. Then rho 3 xy would be d of xy, and since D be a metric space, so it will satisfy the triangle inequality. That means obviously this is less than equal to d of xz comma d dash zy, and since d of xy greater than d dash xy, that means this is less than equal to maximum of d of xz comma d dash xz plus maximum of d of xz comma d dash d of zy comma d dash zy. This is nothing but this is rho 3 xz plus rho 3 zy. That means rho 3 xy less than equal to rho 3 xz plus rho 3 zy. That means triangle inequality also satisfied here. Rho 3 xy be a metric space. Fourth example, consider rho 4 xy equal to minimum of d of xy comma d dash xy. We have to prove rho 4 is a metric space on the set X. Similar to before, this will satisfy first three condition. Obviously this is greater than equal to 0 and equal to 0 when x equal to y, and symmetry property also will be satisfied. But it will break the triangle inequality. For triangle inequality, consider 3 point xyz belongs to x and consider d of xy greater than d dash xy. Then obviously rho 4 xy would be d dash xy, and d dash, but here it will always not satisfy d dash xy less than equal to minimum of d of xy comma d dash xy. For this, consider some particular point. Consider d of xy equal to 6 and d dash xy equal to 8. Also consider d of xz equal to 3 and d dash xz equal to 4, d of zy equal to 7 and d dash zy equal to 2. And notice here d and d dash both had satisfied the triangle inequality because 6 always less than equal to 3 plus 7 and 8 less than equal to 4 plus 2. But rho 4 xy, which is actually equal to minimum of the set d of xy comma d dash xy, and notice minimum of d of xy and d dash xy is 6, which is less than equal to rho 4 xz plus rho 4 zy. Okay. Notice rho for xz equal to minimum of d of xz comma d dash xz and rho for zy equal to minimum of d of zy comma d dash zy and minimum of d of xz comma d dash xz, notice here equal to 3 and minimum of d of zy comma d dash zy equal to 2. That means this is equal to 3 plus 2 equal to 5. That means 6 less than equal to 5. This is cannot possible. So for this condition, triangle inequality has broken here. Are you getting the relation? Oh, all of these are actually the induced matrix which I have defined. What is the induced matrix in my previous video? And not only for this example, sum of two matrix always matrix space, but product not be matrix space. This type of example, actually this is not just example, this is actually some property of induced matrix. This is very important. When D and D dash be any matrix space, then their sum always be matrix space. But product not matrix space. Maximum always matrix space, but minimum not be matrix space. We will see another type of induced matrix space. Consider D be a metric for a non-empty set X. Let D star xy equal to k times dxy. Then D star is a metric on X where k is any positive real number. Here this D star obviously be induced metric. And this proof is very easy type proof. I have left it for all my viewers. Just try to own self. And if you have any queries about this example, please do comments in the comments box. And I hope my all viewers have clearly understood what is the induced matrix. Okay? Oh, now I will see another induced matrix. If XD be matrix space, then D star xy equal to D of xy over 1 plus D of xy. Where for all xy belongs to X, obviously this D star also be matrix space on the set. And this is obviously very easy type proof, but I will prove it because this proof is very important for not only comparative exam, for all exam. And the proof is such type similar to before. Since D is a metric on the space X, then obviously D of xy greater than equal to 0. Then 1 plus D of xy greater than equal to 0. Then that implies D of xy over 1 plus D of xy greater than equal to 0 for all xy belongs to X. And this is actually D star xy. So obviously D star xy greater than equal to 0 for all xy belongs to X. Are you getting? Oh. Second, we have to prove D star xy equal to 0. And D star xy equal to 0 means D of xy over 1 plus D of xy equal to 0. And since 1 plus D of xy always greater than 0, strictly greater than 0, then that imply obviously D of xy equal to 0. And since D is a metric space, so obviously D of xy equal to 0 imply x equal to y. And obviously D star be a symmetric because since D is a metric space, so D of xy always D of yx, and this is also D of yx, and this is actually nothing but D star yx. That means D star xy equal to D star yx. That means symmetric property also here satisfied. Now we have to prove the triangle inequality. Since D is a metric, so obviously this satisfies this condition, this triangle inequality. So we can write d of xy less than equal to d of xz plus d of zy. Also here we can write this part also, less than equal to d of xz plus d of zy. That means from this expression we can write as this is less than equal to d of x comma z over 1 plus d of xz plus d of zy plus d of zy over 1 plus d of xz plus d of zy. And when I will decrease the value of denominator, then this would be just, the value would be, this value would be just increase, because as for example 6 over 2 equal to 3, but 6 over 3 equal to 2. So if we omit this part from this denominator and this part from this denominator, then obviously this is less than equal to d of xz over 1 plus d of xz plus d of zy over 1 plus d of zy. And this is actually less than equal to d star xz plus d star zy. That means d star xy less than equal to d star xz plus d star zy. That means triangle inequality also has satisfied here. Therefore, obviously this d star b induced metric on the space X, because all property has satisfied here. Okay. Today I will stop here, but at first I will highly recommend you, please see today's video with pay attention, because this type of example are very important for not only higher study, for any competitive exam to calculate any metric space easily. I will discuss this type of example elaborately in my next video also. See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos.